Okay, so we'll get started, guys. It's 6:33. So in our earlier class, we did discuss various connectivity models, inter-site connectivity. I think we did discuss express route, right? Sudeep, Naveen, did we discuss express route?
Balancer configuration we have discussed.
Okay, so I think that's the only one because practically we'll not be able to see that. I'll have a quick check
Yes.
on the videos. Okay? Right.
Yeah,
So what
okay.
we are going to cover is in today's class, we are going to cover load balancing solutions. Okay. Now you might have already know a little bit about this, how the load balancing will work. So before we go and talk about specific load balancers, so Azure provides you various load balancing solutions. Azure load balancing solutions are four, which means you get four different load balancing solutions. One we call it as Azure load balancer. So this is also called as ALB, Azure load balancer. Azure provides you another load balancing solution called as application gateway. Okay, this is another load balancing solution. The third load balancing solution, what Azure provides you is traffic manager. Traffic manager. And the fourth load balancing solution, what Azure provides you is front door. Okay. So these are the four load balancing solutions that which you get on Azure. So based on your requirement, based on the scenario that which you have, you will be what do we call it as selecting one of these load balancing solutions. Okay. Now, so the first load balancing solution, which is Azure load balancer, first and second. Okay, the first and second load balancing solutions, they are regional load balancing solutions. They are regional load balancing solutions. Regional load balancing solutions. The other load balancing solution, the other two, they are global load balancing solutions. These two are global load balancing solutions. Okay, these are all global load balancing solutions. So based on our requirement, we will be choosing one of these four. Okay. For Azure administration, so you should be aware of the first two load balancing solutions. Okay. I am going to give the videos of third and fourth. You can watch it in case if you are interested. Okay. But for Azure AZ104 exam, the first two load balancing solutions are there as a part of the what do you call it as assessment content or course content. Okay. So the other two, while I'm not going to cover here in the class, those two will be provided as a videos to you. You can go ahead and look into them. Okay. Spend some time on them as well, so that even tomorrow when you take an architect course, it will be easy for you to understand. Right. Okay. So then we'll start with our first load balancing solution, which is Azure load balancer. So the load balancing solution itself named as Azure load balancer or ALB. Right. So Azure load balancer or ALB, it is layer 4 load balancing solution. It is which layer it will sit? It is a layer 4 of TCP/IP, layer 4 load balancing solution. Okay. So which means your Azure load balancer will support various types of load balancing. What do you call it as scenarios? Okay, it supports both TCP and UDP protocols. So which means you can use various applications to load balance this particular. By using this particular load balancer, you can load balance different types of applications. So you can load balance web applications, you can load balance SQL, you can load balance maybe, let us say, SMTP services, or maybe you can load balance, let us say, mail services and other stuff, right? So you can use this particular load balancer to load balance different types of applications. So Azure Load Balancer is a layer 4 load balancing solution that is, it supports both TCP and UDP, and you can not only load balance web applications, but you can also load balance other applications as well. Okay, now your Azure Load Balancer comes with two types of Azure Load Balancer. So your Azure Load Balancer comes with two types of load balancers. Okay, so one we call it as private or internal. The other one is public or external. Right? So this is public or external. So which means I can configure my Azure Load Balancer for internet users, which will be a public load balancer. I can configure Azure Load Balancer for my private users, which means within the corporate network, if you want to host an application and you want to load balance, you can use Azure Load Balancer for internal or private network as well. So when you're going with public load balancer of Azure, your Azure Load Balancer require what IP address? It requires public IP address, isn't it? Because it is accessed over the internet. If you are going with private load balancer, your load balancer require what IP address? It requires private IP address. So how does your load balancer get private IP address? It should be part of VNet and subnet, isn't it? It should be part of VNets and subnet. So that's how your load balancer will get private IP address. So your Azure Load Balancer can be configured as an internal or private load balancer. So to access the applications within the corporate network or within the cloud infrastructure, so this private load balancer requires a private IP address. And your Azure Load Balancer can also be configured as a public load balancer. Obviously, the load balancer requires a public IP address. Right? Now, your load balancer comes with two SKUs of Azure Load Balancer. So what is a SKU? SKU stands for model, right? Or edition type or whatever you can call it as. So based on the features you need, you will be selecting the right SKU. So your Azure Load Balancer comes with two SKUs. One is called as basic SKU. The other one is called as standard. Right? Your Azure Load Balancer comes with two SKUs. One is basic, the other one is standard. So what is the difference between the basic and standard is the features that which you get within the load balancer will be different when you go with one of these two SKUs. So during the deployment of your load balancer, you not only tell Azure what type of load balancer you are going to go with, that is private or public, you also tell Azure what SKU you would like to go with, whether you want to go with SKU of basic or whether you would like to go a load balancer of SKU standard. Now let us try to understand the difference between Azure Load Balancer basic and standard. Okay. Now for this, I'll take you through the documentation. Right. So we can quickly look at Azure Load Balancer basic versus standard. Right, so there's a very good table here which will help us to understand the difference between a standard load balancer and basic load balancer. So one of the very important thing that which you should know is there is no SLA for basic, there is 99.9% availability for standard, which means for your production load, you obviously go with what type of load balancer? You always go with standard load balancer. Unless it is a testing environment, you don't go with standard. You can go with basic for testing or maybe non-critical applications, but you definitely have to go with standard load balancer for production workloads because there is no SLA for basic. This is the first difference that which you should be knowing. which means obviously in the real-time world, in the production environment, what load balancer you deploy? You always deploy standard load balancer. Now, the other differences that which you need to understand here is the backend pool. Every load balancer will have a backend systems or instances, which we'll be seeing in a while. So you can add IP addresses of the VMs as a backend pool, or you can add network interface card of the VMs as a backend pool when you go with standard. But when you go with basic, you can only add network interface card, which means you cannot add IPs here. And the other difference that which is very important is how many front-end IPs I can configure. One load balancer can have multiple front-end IP addresses, right? If this is your load balancer, it can have multiple front-end IP addresses. A front-end IP is an IP used by your user to access your application. A front-end IP is a load balancer IP address, which is used by your user to connect to your application. So how many such IP addresses can be assigned to a load balancer when you go with standard? You can go with 600 front-end IP configuration, but when it is basic, only 200 IP configurations. And when we talk about the backend pool, so if this is a load balancer, you definitely have your backend pool, maybe virtual machines. And how many such virtual machines can be added as a backend pool is also defined by your SKU. So if you go with standard, you can go up to 1,000 instances at the backend, which means I can add 1,000 virtual machines as a backend pool. But when I go with standard, the limit is 300. Right? That is another difference. Now, the other difference that what you should be aware is here standard load balancer supports virtual machines of any type. Right? You can add any virtual machines to a standard load balancer as a backend pool. And you can also add virtual machine scale set, which is an auto scaling solution that can also be added as a backend pool to your load balancer. But when we talk about basic load balancer, you can add virtual machines in a single availability set, right? So in a single availability set, what is an availability set? It is a high availability solution, which we'll be discussing in our upcoming classes. But remember, here you can add any virtual machines, whether they are part of availability set, whether they are not part of availability set, doesn't matter. But here you can add virtual machines that are part of an availability set itself. And individual virtual machines cannot be added here. So that is the difference. Right? And of course, here also you can use virtual machine scale set. Here also you can use virtual machine scale set. Now, your load balancer has to test the health of the backend resources, isn't it? Whether they are healthy or not, then only it has to route the traffic to those instances. So when your load balancer has to test the health, right? When your load balancer has to test the health, you should be telling on what protocol. They go on mute. Right. So your load balancer has to check the health of your backend instances. That means you need to tell on what protocol the health should be checked, right? So it supports all the TCP protocols. It also supports HTTPS, but here HTTPS is not supported, right? So that is some difference that which we should be aware. And the other important difference is this is zone redundant, which means you get high availability here. Here you don't get high availability for your load balancer. Okay, so the load balancer by itself can be configured with high availability solution. Here you don't have that option, right? So these are some of the differences that which you should be aware. I am giving you this link. Have this link as a reference. Read the content, because you definitely come across these questions in the interviews asking the difference between standard and basic load balancer. Okay, so that is very important to be aware that what is the difference between standard and basic load balancers. right? Now, with this understanding, so let us go ahead and try to deploy a simple scenario, right? And understand how this load balancing solution will work. Okay. Now, so what we will do is we'll deploy some web servers. Okay, I'm going to deploy two web servers. Call them as WS1 and WS2, and we'll install IIS web services on them. And then to load balancer these web servers, we are going to install an Azure load balancer. Okay, so we are going to install an Azure load balancer, right? So every load balancer will have a front-end configuration, right? So the front-end configuration is nothing but the front-end IP address and the port that which your users will use to access the load balancer. So what will be there in the front-end configuration? Front-end configuration will have what, guys? Front-end will have an IP address. It can be either public or private based on the load balancer type you select. And it will also have the port, right? On what port your users will be accessing it. Maybe it is 80 or 443 if it is web application. And your backend pool will have these instances, which are either virtual machines or virtual machine scale set. This is what your backend pool. Right now, your load balancer will talk to this backend pool, either to the individual machines or maybe to an availability set, hosted virtual machines, or to a virtual machine scale set. Now, your load balancer should also test the health of these instances, isn't it? So that's where a health probe will come into picture. Health probe is nothing but your load balancer will periodically check the health of those instances. And how does it check? That you need to define. If it is a SQL application, you say that check the health on 1433, which is SQL Server port. If it is a web application, check the health on 80 or 443 or 8080. If it is some other application, that application service should be configured to test the health. So your load balancer will periodically test the health of these instances by polling them, by checking them, isn't it? Now, if there is no response, it removes this instance from the load balancer. It won't send the traffic to that instance. Anyway, it will periodically test unless until it is back. When it is back, it will be added back to your load balancing, isn't it? That's how it will work. Okay. So if it is a web server, the health probe will be on what port? So HTTP or HTTPS. So in this case, we are going to use HTTP itself. In this case, the health probe will be on port 80. Right? So you got a front-end configuration, you got a back-end pool, you got a health probe. Now, Azure load balancer will also get something called as load balancing rules. Load balancing rules. A load balancing rules, what it basically does is it binds your front end with your back-end pool and with your health probe. So load balancing rule is nothing but it stitches or combines your front end configuration with your back end pool and health probe. Excuse me, I'm sorry guys. And there will be a couple of other settings like whether you would like to go with session persistence or not and so on. Those are the configurations that which you configure by using a load balancing rules. So what do you do? First, you deploy the load balancer, configure the front end, add the backend pool, define the health probe, and bind all these together by using health probe rules. That completes your configuration. Okay. Now, so let us quickly go ahead and deploy this environment. Okay. Now, first step, let us go and deploy two web servers. Right. Let us log into the Azure portal. Right. So go to the virtual machines. So deploy two virtual machines. I'll call this as web server 1, right? So let it be in central US. So let's deploy a Windows 2019 server and username password. Right? So let us create a VNet here. So let us create a VNet with the name VNet1. And let us create a subnet. Let us call it as subnet1. Right? And go and deploy this first web server. So we'll deploy one more server and we'll install IIS web services on these machines. So once we have these, then we'll go ahead and deploy a load balancer and we'll see how the load balancing solution will work. So while this goes on, I'm just waiting for that VNet to get created. So once the VNet is created, then we can go ahead and deploy the second VM as well. Because remember, whether it is application gateway or whether it is Azure load balancer, you can add instances to the backend pool. The other way you can add the instances in the same VNet, right? So all the backend pool instances should be in the same VNet. You cannot add backend pool instances spanning across multiple VNets. Okay, so that is something that which you need to be aware of. Which means I cannot add web server. Maybe let us say web server 1 is in VNet 1, web server 2 is in VNet 2. If I'm adding web server 1, which is in VNet 1, I cannot add web server 2 because it is not in the same VNet. So all the backend instances should be in the same VNet, right? So when you go with application gateway or when you go with Azure load balancer. Okay, it's very important point. Right, your VNet is created and it has also got subnet. So what we'll do is we'll deploy our second virtual machine. Hopefully we will be able to see that VNet. Web server 2, same Windows 2019, username, password. Right, so it should be in VNet 1. No, that's the problem. It is not allowing us to deploy. So while that gets replicated, we'll do one thing. We'll go and deploy our load balancer. Okay. So I assume that we deployed both web servers. Okay. So let us go with the load balancer deployment. Okay. So to deploy the, we'll create the other instance. Don't worry. Okay. We'll deploy Azure load balancer. Right. For that, you go to the service called as load balancers. You see this load balancer service. And as I said, you see 4 types of load balancer: application gateway, Azure load balancer, traffic manager, front door. Right now we are discussing about Azure load balancer. Right now, so you can see this built-in load balancing for cloud services and virtual machines. You can create highly available and scalable applications in minutes. Load balancer supports both TCP and UDP based protocols. Right, you can use that for any of the application to load balance. So I'm creating a load balancer. Right now, it is a layer 4 load balancer. All right. and it uses an algorithm called as 5-tuple hash. Okay, what algorithm it uses? It uses an algorithm 5-tuple hash. Okay, so the 5 tuples are nothing but source port, destination port, and protocol type. Okay, now so let us go and deploy our load balancer in MSDN subscription in a resource group. Let us name this as my load balancer. Now here is where you see what type of load balancer you would like to go with, basic or standard, right? That's the difference. That is skew, right? So we'll go with standard load balancer. And the next question what it is asking you is whether you want to go with public or internal load balancer. So when you go with internal, which will be the load balancer is to load balance your internal application within the corporate network. When you go with public load balancer, which means the application will be accessed over the internet, is it? So when you go with internal load balancer, the front end configuration, when you say next, the front end configuration asks you the VNet and subnet, isn't it? It will ask you VNet and subnet. But when you go with public load balancer, it won't ask you to specify the VNet and subnet. Rather, it will ask you to what do we call it as create a public IP address. Okay. Now there is another very important setting here, which is tier. Okay. So the load balancer tier. This is recently added option. Okay. So the load balancer tier is of two types. Okay. So load balancer tier is of two types. One is called as regional. The second one is global. Right. So regional tier and global tier. So most of the times you deploy a load balancer with regional tier itself, but there is also this option called as global tier. Then what is the difference between regional and global? When do I use a regional tier? When do I use a global tier? Let us try to understand that part. Okay, right. So let me give you a scenario, okay, so that you understand it clearly. Now I assume that there is this load balancing solution, and you deployed this load balancing solution in central US. Right, you deployed this in central US location. And what you did is to make sure that your users can access the application when central US is not available, you want to make sure that users should access the application. Then what you did is you went ahead and deployed similar configuration in another region. Okay, so maybe let us say you deployed similar configuration in East US. Right? So now your users should be able to access East US site in case if Central US region is not available. So then what do? You give two URLs to your users. That is one way of handling it. So you tell that bus always use Central US. If Central US is not available, access the URL of East US. That is one way of doing it. So the other way of doing it is every load balancer will have an IP address, isn't it? Let us say A dot B dot C dot D is this IP address. Maybe let us say E dot F dot G dot H is this IP address. And maybe your users use some DNS name or name, let us say, what do we call it? How do we XYZ dot your domain.com. Let us say this is a URL they are using, right? So this URL will obviously be mapped to that public IP address, isn't it? So let us say you mapped this URL to this public IP address, right? In case if this region is not available, what I can do is I can edit this, right? And I can edit this record on DNS server, and then I can find this record to this one, right? So your users will not be able to see that they, there is something down, and then they are redirected to a different region. They'll not be able to know that, but there will be a definitely little downtime, isn't it? Here, whenever you update those records, it takes time for you to know that it is down, and then it takes time for you to update the records and so on, right? So two solutions I explained. One, give two URLs to the users to access this and this, and give only one URL. If this is down, then modify your DNS records to point to the other region public IP address, right? That is the second solution. Now these two solutions, there is a manual intervention, right? So there is a manual intervention, and then you need to be aware that the services are down, then you need to take actions, or user should be connecting them. So instead of that, what you can do is you can deploy another load balancer. So another Azure load balancer, and this is of tier global. And what this global tier load balancer does is it will load balance your Azure load balancers. So the backend pool for your global load balancer, the backend pool for your load balancer of the global tier is what? Your Azure load balancers. You cannot add VMs to this, right? So now your users will be accessing this particular load balancer. In case if this region is down, your load balancer is aware and route the traffic to this particular load balancer in other region, right? So that's how you can use this global tier, right? So if you are going with global tier, the backend pool will be your load balancers, right? When you go with regional tier, the backend pool will be your VMs or virtual machine skill sets. When do you use global tier? Scenarios like this, where you have same applications in two regions, and then you want to have high availability for it, then you can go with this global tier, right? So that's what this tier is all about, right? So by default, it is regional. Okay, so we'll leave that regional. Now, front-end IP configuration. So we have to create a front-end IP configuration. For that, I'll give the name as my front-end, my load balancer front-end. And then I need to specify what public IP address I would like to use, whether IPv4 or IPv6. And I need to create a public IP address here. I'll say my load balancer front-end public IP address. Okay. So I'm creating a public IP address, and I'm assigning this public IP address as a front-end. Okay. So your load balancer will have a front-end with a public IP address, right? You can configure backend pool. This we will be doing after the load balancer is created. So we'll go ahead and review and create, right? Review and create the load balancer. So we can add the backend pool after the load balancer is created, right? So let this get deployed. Let us see our VNet problem is fixed. Still not visible. So even that will be a problem when we try to add the backend pool. So you can see I'm here in the load balancing service. Your load balancer is deployed, right? So if you go to your load balancer itself, this is how your load balancer looks like, right? So under the settings, you see the front-end IP configuration, right? You can see the front-end IP configuration, which is, this is the front-end IP address of your load balancer. Okay, this is the front-end IP address of your load balancer. You can add backend pools from here. You can add health proofs from here, and you can add load balancing rules as well, right? Now, so we have a front end. So your users will be using this IP address to hit the load balancer. Okay. Now let us try to add the backend pool. Here also we need to pick the VNet. So let us see if the VNet is visible. It says it is not. I cannot see the VNet. So that's the problem there. Let us try to log out and re-log in. So if you go to the backend pool, you need to add the backend pool by hitting add. So, okay, so now it is visible, you see it, right? So we'll go and create another virtual machine and then we will come back to that load balance, okay? So in this particular picture, we have one web server. We are deploying the second web server, isn't it? So that is the requirement which we are working on. Web server 1 is there. I'm adding another web server in the same region, in the same subscription, resource group, isn't it? So let us call this as DJ WS2. So let us deploy a Windows 2019 local admin credentials. Right? And networking section, I'll make sure that it is sitting in VNet 1 and subnet 1. Okay. Go ahead and create your backend instance. Right. So we need to install IIS web services on these two machines. Right. We need to install IIS web services. For that, we'll use a PowerShell command. Okay. So the PowerShell command which I'm going to use is install -Windows Future web hyper server. So this installs IIS web services on the Windows machine. Okay. So in order to install the IIS web services, I need not have to log into the virtual machines. What I can do is I can go to the virtual machine. So there is this option called as run command. Okay. So there is this option called as run command. So in this run command, I can run a PowerShell script or PowerShell command. Okay, you see this option, run PowerShell script. I go to that and I'll put my PowerShell command here. Right? Install -Windows Feature web -server is basically going to install our IIS web services role on this WS file. So I'm installing this without logging into this server. Okay, so go ahead and run this. So this command will be executed on this particular web server and IIS web services will be installed on it. Okay, so that's like that you can install IIS web services without logging into the machine. You can run any command. Okay, so you can run any command without logging into the machine. Okay, so let us also do the same thing on the web server too. So go to your web server too. And I'm going into this option called as run commands. And I'm going to go and install IIS web services on this one as well. Okay. So now both the servers will have IIS web services on them once this command is successfully executed. Right. So which means you got this backend pool with the required configuration in place. We also got a load balancer with front-end configuration. The next step, what we need to do is we need to add these two instances as a backend pool to this load balancer, isn't it? That's our next step, right? So let us go to our load balancer. I'm opening in a new tab because it will take for some time for them to run that script. So go to your load balancers. Go to your Azure load balancer. What do we need to configure? Backend pool. So add backend pool. So name of the backend pool is my backend pool. Some name. Now where are your virtual machines, right? Where are your backend instances? You need to select the VNet where your instances are. That's why I was saying you can add the instances which are part of the same backend pool. Okay. Now, So a backend pool configuration, do you want to add the network interface card or do you want to add private IP addresses of the backend pool? Which one do you want to do it? Right, we have both options. We'll go with network interface card. Now, it says that no virtual machines found in central US that matches the above criteria. Now, what does it say? We did select a VNet. In that VNet, we have virtual machines, but it is saying that there are no virtual machines found. Why? The reason is that concentrate, very important. Okay. The reason is, read this statement. You can only attach virtual machines in central US because my load balancer is in central US. I can attach virtual machines which are sitting in central US itself. And all our virtual machines are central US. There is no problem with that. We are good with that. And read further, right? You can attach virtual machine in central US that have a standard public IP address configuration. If the VM has got public IP address, what public IP address it should have? It should have standard public IP address. Or the VM should not have public IP address. So if the VM has got public IP address, it should be a standard public IP address or it should be without public IP address. And if your VM has got a basic public IP address, you will not be able to add them here. So we have, so you can see this IS installed. We go to this VM. We got public IP addresses to these VMs. But what public IP address is that? Is it standard or is it basic? If I go to that public IP address, it is a basic public IP address. So that's why I am unable to add these virtual machines. If I go and remove this public IP address, right? If I go and remove the public IP address of both the virtual machines, then I should be able to, I'm going to this public IP address overview, I'm disassociating the public IP address. Okay, right? So once I remove the public IP addresses, I can attach it. I can add them as a backend pool. Now, if you want to have a public IP address, convert the basic public IP address into standard public IP address. We had already seen in our earlier class, how do we convert that? So for you to add a virtual machines as a backend pool, the virtual machine either should not have a public IP address. If it has got a public IP address, the public IP address should be of type standard. Okay, very important, right? So we'll go back and try to add again. This time we should be able to see those, right? Virtual machines. My backend pool, they are on VNet 1. Now I get this add option enabled, right? Because we removed those public IP addresses which were basic, or you would have changed that to standard public IP address. Okay, add these virtual machines, select the virtual machines, and then add them, right? Or you can also add virtual machine scale set, which we'll see in our virtual machine scale set discussion. How do we add them, right? So I added both the virtual machines as a backend pool, right? So go ahead and hit add, right? You are done with the backend pool configuration, right, guys? Now then what you need to do now, you need to configure health probe, right? Let us configure the health probe once it is added. It's taking time, let us wait. Okay. It seems this is added backend pool. Now what do you need to do? You need to configure health pro. Why health pro? Your load balancer should know whether these instances are healthy or not. If they are not healthy, the load balancer will not route the traffic to them, right? So go ahead and add your health pro. Health probe name, my health probe. On what protocol you want to test the health, right? Because it's a web server, I will go with 80. If it is some other application, you can change the port number accordingly. Okay, TCP port 80. Now, by default, every 5 seconds, interval 5 seconds, which means every 5 seconds, your load balancer will test the health of your instances. It polls the backend instances every 5 seconds, right? Now, if there is 2 consecutive, failures of the response, it will treat that the service is dead. Which means if it is trying to poll web server 1, it will poll first, it will wait for another 5 seconds, then it will poll again, right? So once if it is not getting a response after 2 consecutive polls, then what? It will be removed from the load balancer. Okay? So that is the threshold, that is the interval. Okay. So every 5 seconds it checks. If there are no responses 2 times consecutively, then it thinks that the service is not responding and removes the server or the instance from the backend. Right? That is your health probe requirement. Right? Health probe is must. So let that get added. Then we will see how do we configure load balancing rules. Okay, your health probe is added, right? Now let us go ahead and add the load balancing rules. Okay, as I said, load balancing rules will bring all these together, isn't it? So the load balancing rule will have some name. My load balancing rule is the name of the load balancer. So your front end is IPv4. So select the front end IP address. Your backend pool, this is a backend pool that which we added. The front end port is what? Front end port is 80. Back end port is also 80 because it is web server. Sometimes it might also be 8080, right? So it depends on what port this application of your backend services are running. If it is a SQL, then you may have 1433. The front end port also may be 1433. So based on what type of application you are running, these port numbers will change. Okay, so you specified if the traffic is coming from this front end on this port, route it to this backend pool on this port. That is what you are specifying here. Okay, now you are also adding health probe, right? You are also adding health probe, right? So next setting is very important, session persistence. Now what is this session persistence? Let's try to understand. Assume that you got a user and this user is accessing your load balancer. So he uses the front end IP address, isn't it? 20.118.1.135, isn't it? That IP address he uses, or maybe URL associated to that he will use and access it. Now I assume that he opened another tab in the browser and he has another session from the same client machine to this load balancer, which means from the same client IP address, there are 2 sessions hitting the load balancer. I assume that the first session went to web server 1. Then where should be the second session go? By default, the second session goes to the second web server in the backend pool, which means by default, your load balancer follows round robin algorithm or method to distribute the traffic to the backend instances. But the session is coming from the same instance, isn't it? From the same, what do we call it as, endpoint, not instance, endpoint, right? From the same client machine. So it will be good, isn't it, if you route the second session also to the same instance where the first session is, isn't it? Right? So in case if you want to do so, then you will be using this session persistence settings. So session persistence will help you to configure if there are multiple sessions coming from the same client IP address, they will be routed to the same instance at the backend where the first session is routed to, right? That is the session persistence with client IP address. What is the advantage of that? There will be less load on your web server in this particular case, right? Why less load? There can be some shared processes because it is coming from the same IP address. Now, if it is coming from same client IP address on same protocol, now this is any protocol, but in the same client IP address. If it is coming from the same client IP address and same protocol, then you have to follow the session persistence. Okay, so these are a couple of settings which are very useful. Okay, so by default, it will route the first session to the first web server, second, first, second, like that. It will do a round robin allocation. If you want to go, if the session is coming from the same client IP address and you want that to be routed to the same instance where the initial instance is, use the session persistence option, right? Right. And there is also some natting solution in the load balancer, which we will pick. Okay, we'll discuss maybe in tomorrow's class. Okay, so I'm going to go and add this Azure load balancer, right? So this completes the configuration of the load balancer. What did we do? You configure a load balancer with front-end IP address. You configure a backend pool. You define the health probe, and you brought all those together by using a load balancing rules. Okay, so this completes the configuration of our load balancer. Right? So your users can use this front-end IP address, and they will be able to access the backend web services using the front-end IP address of the load balancer. Now, one small change we need to do. We need to go ahead and go to the virtual machines, and we need to enable port 80 at the NSG so that you will be able to access the web services. Because by default it is blocked, so you don't have port 80 added here. So what we can do is we can write a rule adding port 80 to the traffic, isn't it? Same we will do on the web server too. Right? I'm going to web server to networking, add an NSG rule. Right? So port 80, maybe some other priority number, right? So once you have added these rules, then you should be able to access, right? You should be able to access the application, right? So you're hitting the load balancer. The load balancer is routing the traffic to the backend. Okay, that's how your load balancing solution will work. And load balancer has also got another feature, which is natting. Okay, so which is natting. We'll also quickly discuss that. Here, load balancer has also got a feature called as natting. Natting stands for network address translation. What does natting stands for? Natting stands for network address translation. Network address translation. Isn't it? Then what is the use of this? Let us try to understand. Okay. Now assume that your backend instances doesn't have any IP addresses, public IP addresses. Okay. So assume that the web server 1 and web server 2 doesn't have public IP addresses. But you want to access these web servers over the internet. So without assigning public IP addresses to those virtual machines, you want to access them through the public IP address. Then what I have is, I have already a load balancer. I already got a load balancer. This load balancer has got a public IP address, isn't it? This load balancer has got a public IP address, right? So using the public IP address of this load balancer, I will connect it to these web servers. Right, you're getting? Using the public IP address of this load balancer, I will connect it to these servers. That's what your NATing is, or network address translation is. Then how does this work? Let's try to understand. Okay. Now this is the IP address of your load balancer, isn't it? This is the IP address of your load balancer, public IP address. Right? So I'm going to go and write a rules, isn't it? Which we call it as NATing rules. What I'm writing? NATing rules. Concentrate, okay? I'm writing NATing rules. Where do I write these NATing rules? I write them on load balancer, Azure load balancer. So Azure load balancer has got a network address translation or NATing feature where I am writing these NATing rules. And how do I write these NATing rules? Like this, okay? So if Vijay is accessing this IP address, the load balancer public IP address, on port number 50,000, then it should route to VM1 or WS1 on port 3389. If means, if Vijay is accessing load balancer IP address on port 50,000, the load balancer will route the traffic to web server 1 on port 3389. What is 3389? RDP port. Isn't it? Similarly, I'll write another rule. Okay. If Vijay is accessing the same public IP address on different port 50,001, then it should route to other web server, which is web server 2 on the same port. Now, if you got a Linux machine, instead of 3389, you can use port 20, SSH port. So you are going to write rules like this way on your load balancer. So whenever you hit this 118.1.135, you on 50,000 port, you will be routed to web server 1. On 50,001, you will route it to web server 2. On 50,002, if you write a rule, maybe to another server. So without assigning public IP addresses to my servers, I am accessing these servers over the internet. And of course, they are not exposed directly to the internet, isn't it? It means more secure way of accessing them. Right? Now let us see how does this actually work. Okay. Now, so let us go to the load balancer. So let us go to the load balancer. And there is this option called as, under your load balancer in the setting, there is this option called as inbound NAT rules. And I am writing a NATing rule here, add NATing rule. Right? I'll say NAT rule 1. Right? Now, what is your backend? My backend is a virtual machine. And I can select the virtual machine. To which virtual machine you want to connect? Web server 1. What is the IP address of the web server 1? 10.0.0.0.4. Then using what IP address you want to connect? Using this front end IP address I want to connect. The front end port is what? 50,000. Right? Now, when you are connecting to this 21.118.1.135 on 50,000, it should be routed to this particular IP address 10.0.0.4. But on what port? On port 3389, RDP port. Right? Go ahead and add your NATing rule. Right? So we'll add another rule also, second one for second web server. Then we will test it. So the first rule is getting added. We'll also add second rule. Once it is added, right? So second NAT rule I will add for my second server, NAT rule 2, right? So target virtual machine, web server 2, its IP address, front end IP address of the load balancer using which I want to connect to this web server. Front end port, this time I will use a different port, 50,001. To what port it has to route? Again on 3389. To this 10.0.0.5, which is a backend instance, it should be routed. Okay, so go ahead and add yes second NAT. So now you as a user, what you do is you go to this, you go to MSTSC. Now you use this IP address, isn't it? And you access this IP address on port. Which port? If you want to connect to web server 1, you access it on 50,000. Then you should be connecting to what? You should be connecting to your web server 1, isn't it? We should be connecting to web server 1. If you use 50,002 with the same public IP address, if you're using 50,002, right? The same public IP address. If you're using 1 colon 50,001, right? You will connect it to web server 2, right? So here in this case, you are using load balancer public IP address to access your backend instances, and they don't have public IP addresses and they are not exposed to the internet, right? So use the NATing solution within the load balancer to connect to the backend instances without assigning public IP addresses to them. This is your NATing solution which you get within the Azure load balancer. It is an optional feature. If you would like to use it, you can use it. It is not related to any load balancing that which we discussed here. This is a feature available. If you would like to use it, you can use it. Right? So this concludes our discussion on Azure load balancer. Tomorrow we'll be discussing our second load balancing solution, application gate. Okay. So if you got any questions, please ask. Is this concept clear? Okay, so if no questions, we'll meet tomorrow at the same time. I think Raj, you joined late. Just go through the video once. We'll meet tomorrow at the same time, which is 6:30 a.m. IST. Okay.
Sure, Vijay. Yeah, sorry, I went out. I was stuck in the traffic actually.
That's fine. That's okay. Yeah. Right. So we'll meet
Thank
tomorrow
you.
at the same time, guys. Have a great day ahead. Good night, Raj. Bye.
Good night.